Congratulations on hitting the end of this chapter where we were learning about move semantics. And we had a chance to see that move semantics are really a set of features we have in C++ to make it much more performant to construct or assign from temporary objects. If we don't use move semantics, we will be copying from temporary objects, and that will be wasting a lot of time and memory because all the data we have in temporary objects will just be destroyed along with the temporary objects when this little guy is no longer needed. And we saw many ways we can improve on this and reuse the data in our temporaries. But before we embark on the journey to understand move semantics, we had to learn the basics. So we started out by learning about L values and R values. L values are things that have names in your program, or to be exact, variables that have names in your program. And another thing is that you can grab addresses for L values and use them elsewhere in your program. On the other hand, R values are things that don't have names in your C++ programs, so they are temporary objects that are meant to be destroyed the moment they are no longer needed in your C++ program. But R values are really useful in that we can build from them and really steal the data that they have inside and avoid unnecessary copies we would be doing otherwise. Another thing we saw is that we can set up R value references and extend the lifetime of our temporaries. So on this line here, for example, we can extend the lifetime of this temporary we get by adding up X and Y and be able to use this guy later in our C++ program. For example, if we go down here, we can use the R value reference. This is going to work really well. If we didn't extend the lifetime of this temporary here, it would be destroyed the moment we hit the next line, and all the data that was set up here will be destroyed and you won't have access to that anymore. But if we attach an R value reference to this temporary using the syntax we have here, this guy is not going to be destroyed. It is going to be available even when we hit the end of our C++ program, like we see in our main function here. So R value references are really cool. We saw that if you try to move temporary objects around in your C++ program, you will get copy semantics by default. So if you're trying to do construction or assignments, you will either call the copy constructor, which is going to be copying data from the source object, or you will call the copy assignment operator, which is going to be again copying from the source object, throwing away all the hard work we did to set up a temporary object. If we want to get move semantics, we need to set up a move constructor and a move assignment operator, and we can do that like we see here. So we can set up our move constructor using the syntax here. We pass an R value reference. We can set up a move assignment operator using the syntax we see here. We pass an R value reference. And please remember not to put the const in front here because you really intend to modify the source object when you invalidate the pointers inside after you steal from it. That's why we don't need a const in front here. If you put a const, the compiler is probably going to see that it can't modify your source object, and it is going to choose the copy constructor and do copy semantics, even if you went through all the hard work to set up your move versions to get move semantics for your type. We had a chance to see that it is possible to even steal from L values, and the way you do that is to insert an std move when you intend to do a construction like we have here, or when you intend to do an assignment like we do here. We also had a chance to stress that you should really try your best and leave objects you steal from in a good state so that they don't become confusing to other programmers working on your code, or even confusing to yourself at a later time when you come back and work on your code base. So a good practice is to reset the pointers in the object you steal from. So in our move constructor and move assignment operators, we made sure we invalidate the pointers in source. So after we steal from this box container object, the pointer in box 1 is going to be reset to null. And that's going to be really good. People will have the ability to check for null pointers before we do things with pointers in box 1, and this was really cool. But we also had a chance to see that we can reuse our box 1 object. For example, down below here, we can add data back in box 1, and we saw that this could work. So you can set up really this however you want in your C++ program. And we had a chance to see that you can set up move-only types. And the way you do that is to delete the copy constructor and the copy assignment operator. And your type will only handle move semantics using the move constructor and the move assignment operator. We close the chapter by looking at what happens if you pass R-value references to functions. We saw that if you happen to give your R-value references names, the compiler would treat them as L values. And to get move semantics in that situation, you have to insert those R-value references into an std move call to force the compiler to treat them as R-value references. We saw that we also get the same behavior, for example, on our box container class. If we set up another add version to do move semantics, if we are not careful and directly do an assignment like this, we will get copy semantics because the item object here has a name that it got from this parameter here. So if we want to move semantics, we have to be careful and put an std move here. And this is going to give us move semantics that we crave. This is really all I had to share in this chapter. I hope you found it interesting. We are going to stop here in this one. In the next one, we will start and learn about function-like entities. Go ahead and finish up here and meet me there.